Imagine a rock so large and moving so fast, its impact could change the course of life on Earth. This isn't the plot of a blockbuster movie, but a reality that exists within our cosmos. We're talking about asteroids. These celestial travelers are more than just space debris. They're keys to understanding our past and potentially influencing our future. Formed from the primordial material that coalesced to create the solar system, asteroids are like time capsules, containing secrets about the birth of our universe. They've also been game changers in Earth's history. Remember the dinosaurs? Their reign was cut short by a colossal asteroid impact, a testament to the transformative power these space rocks wield. But asteroids aren't just harbingers of doom. They're also targets for scientific exploration and potentially valuable resources. So as we delve deeper into the mysteries of the cosmos, it's clear that asteroids have played a significant part in our past, and they may hold the keys to our future. 65 million years ago, a catastrophic event sealed the fate of Earth's most dominant creatures, the dinosaurs. This event, known as the Chicxulub impact, was the result of a colossal asteroid, roughly 6 miles wide, slamming into what is now the Yucatan Peninsula in Mexico. This impact was nothing short of apocalyptic. The energy released was equivalent to billions of atomic bombs, and it caused wildfires, tsunamis, and a global winter that lasted several years. The dust and soot thrown up into the atmosphere blocked the sun, causing a dramatic drop in global temperatures. This sudden climate change led to the extinction of about 3/4 of all species on Earth, including the non-avian dinosaurs. However, while this event was undoubtedly destructive, it also had a transformative effect on the evolution of life on Earth. With the dinosaurs out of the picture, mammals, which had previously been small and insignificant, began to thrive and diversify. Over the course of millions of years, these mammals evolved into the myriad forms we see today, including us, humans. The Chicxulub impact is a stark reminder of the power and influence asteroids have had and continue to have on our planet. These celestial objects, often dismissed as mere rocks floating in space, have the potential to drastically alter the course of life on Earth. This event is a testament to the fact that what happens in the cosmos doesn't stay in the cosmos. It has direct, tangible effects on our world and our lives. It's also worth noting that the Chicxulub impact isn't an isolated event in Earth's history. There have been several other asteroid impacts throughout our planet's 4.5 billion year lifespan, some possibly even larger than Chicxulub. Each of these impacts has, in its own way, shaped the course of life on Earth. The Chicxulub impact was a turning point in Earth's history, a reminder of the power these celestial objects possess. It's a testament to the fact that we, as a planet and a species, are part of a much larger dynamic cosmic system. And it's a reminder that to understand our place in this system, we need to look not just at the world around us, but also at the sky above us. What if history repeats itself? What if another asteroid is on a collision course with Earth? Let's imagine for a moment, an asteroid the size of Chicxulub is hurtling towards our home planet. It's a chilling thought, isn't it? The immediate impact would be catastrophic. Cities would crumble under the force, and the dust and debris thrown into the atmosphere could block out the sun, plunging the world into a nuclear winter. This could lead to a collapse in the food chain, resulting in mass extinction of many species, possibly even our own. Early detection is our best defense. The sooner we identify a potential threat, the more time we have to develop and execute a plan to deflect the asteroid. That's why space agencies worldwide are investing in asteroid detection and deflection technologies. While this scenario is hypothetical, the threat is real, and the consequences could be catastrophic. NASA and other space agencies around the world are not sitting idle. They are actively working on strategies to monitor and deflect asteroids that could pose a threat to our planet. One of the most significant initiatives in this regard is the OSIRIS-REx mission. Launched in September 2016, OSIRIS-REx embarked on a journey to Bennu, a near-Earth asteroid about 500 meters in diameter. The mission's goal? To study Bennu up close, collect a sample, and bring it back to Earth. But why go to all this trouble? Well, asteroids like Bennu can teach us a lot about the history of our solar system. They're like floating time capsules from billions of years ago, holding information about the early solar system and possibly even the origins of life. Beyond the pursuit of knowledge, there's also a practical aspect to missions like OSIRIS-REx. By studying how sunlight affects Bennu's orbit, a phenomenon known as the Yarkovsky effect, scientists can better predict the paths of asteroids and assess their threat level more accurately. And it doesn't stop there. NASA is also testing out potential deflection methods. One such effort is the Double Asteroid Redirection Test, or DART for short. In 2022, DART will crash into a small asteroid's moon at a speed of 6 kilometers per second, aiming to change its orbit. The mission will test whether we could nudge a threatening asteroid off course if we had to. You see, these aren't just theoretical exercises. They're essential steps in preparing for a potential asteroid impact. By understanding these celestial bodies and testing mitigation strategies, we're not just expanding our knowledge, we're actively safeguarding our future. It's a fascinating time in the world of asteroid research and mitigation. With each new mission, we're not only uncovering the secrets of the universe, but also developing the tools and techniques needed to protect our home planet. Through missions like OSIRIS-REx, we are not only learning more about asteroids, but also developing ways to protect Earth. Not all asteroids are created equal. Indeed, the composition of an asteroid significantly influences the type and magnitude of damage it can cause upon impacting Earth. Asteroids are primarily made up of two types of materials, iron and stone. Iron asteroids, also known as M-type asteroids, contain a high percentage of metals, predominantly iron and nickel. These dense, heavy celestial bodies can cause massive damage if they collide with our planet. Their high density allows them to penetrate deeper into the Earth's crust, creating larger craters and causing stronger shock waves. On the other hand, stony asteroids, or S-type asteroids, are composed mostly of silicate rocks. They are less dense than their iron counterparts, but are more abundant in our solar system. These asteroids tend to break up upon entering the Earth's atmosphere, often resulting in a meteor shower rather than a single large impact. However, if a large stony asteroid does manage to reach the Earth's surface, it can still cause significant damage, as was the case with the Tunguska event in 1908. The size, speed, and angle of an asteroid's impact further influence the damage it can cause. A small asteroid hitting the Earth's surface at high speed can cause more damage than a larger one moving slowly. Similarly, an asteroid striking at a sharper angle can cause more devastation than one hitting at a shallow angle. The composition of an asteroid also plays a role in how it reacts to potential deflection methods. For instance, a kinetic impactor might be effective against a stony asteroid, but could simply break apart an iron one, potentially creating multiple hazardous fragments. So while Hollywood may favor the image of a massive iron asteroid hurtling towards Earth, the reality is much more nuanced. The diversity in asteroid compositions adds layers of complexity to both the threat they pose and the strategies we develop to mitigate that threat. Understanding an asteroid's composition is crucial in predicting its potential impact effects. Every day, telescopes around the world keep a watchful eye on the sky. They're not just looking for stars and galaxies, but also for near-Earth objects, or NEOs, asteroids and comets that orbit close to our planet. Among these NEOs are Bennu and Apophis, two asteroids that have caught the attention of scientists worldwide. Observing these celestial bodies provides us with crucial insights. We can study their orbits to predict potential collisions with Earth. We learn about their composition, which can tell us not only about the potential damage an impact might cause, but also about the early history of our solar system. Moreover, by monitoring their motion, we can test and improve our asteroid deflection strategies. This continuous vigilance allows us to be proactive. We can identify potential threats years or even decades in advance, giving us time to take action if needed. Monitoring near-Earth objects is our first line of defense against potential asteroid impacts. Asteroids are not just a subject for scientists, but something that can pique everyone's curiosity. They represent the unknown, the fascinating, and occasionally the terrifying aspects of our universe. Becoming part of this exploration is simpler than you might think. You don't have to be an astronaut or a scientist. Even a spark of curiosity can lead you on a journey of discovery. Learn about asteroids, about the missions that study them, about the risks they pose, and the benefits they could bring. Support space research. It's through these initiatives that we can better understand and potentially protect our home from these celestial wanderers. Encourage the young ones to reach for the stars, to dream about what lies beyond our world. As we continue to explore the cosmos, remember that every one of us has a role to play in understanding and protecting our planet.